Hello participants, welcome to micro irrigation engineering subject lecture 36. Lecture 36 is kept for design and development of drip emitter. We discussed in the basic components of micro irrigation system, and if you remember, dripper is one of the important component of the irrigation system, micro irrigation system, where water is emitting out at a constant flow rate in a given pressure. So, in this lecture you will understand how the basic fundamentals of fluid mechanics have been utilized to develop, to design drip emitter. So, in this lecture we will be discussing about what is the basic theory involved and what are the different design steps, how to make the simulation of water flow in the dripper, and how the prototype development of dripper it has been done, and then is testing. Dripper is the important component, it is a critical component of micro irrigation or drip irrigation system. The purpose of a dripper is to dissipate pressure so as to deliver water in the form of droplets or continuous tiny stream, and then the water which is coming out of the dripper, it is at a non erosive velocity. It does not make erosion when it falls on the ground surface. So, when water is flowing from the through the dripper, water is in this component, if it is a 3 component dripper which is commercially available in the market. Just I want to show you here a typical dripper which is a 3 component dripper. Water is entering from the this through the barb, and this is the base of the the means this is the bottom base of the dripper. This is the outer base of the dripper. Inside these 2 components, means this is the housing where this particular component is fitted. This is a labyrinth button. So, water which comes from the barb, there is a small hole, and through this hole water enters and it passes through this dentate labyrinth path. So, water which it comes, it gets there is a turbulence flow, it takes place, and this is the energy, this particular component is energy dissipator, and finally, it comes out of the outlet. So, the flow which it takes place, it is a interesting phenomena, and let us try to understand the basic philosophy or basic fundamentals of flow which takes place through a dripper. There is a relationship between the pressure and discharge from the emitter or drip emitter. It is given by the discharge from a drip emitter is as a Q equal to coefficient of discharge multiplied by the operating pressure to the exponent power operating pressure P and exponent x. So, here discharge it can be expressed in liter per hour. K is the coefficient, it will depend upon the type of dripper, how the flow it takes place, and then X defines the particular type of emitter it belongs. This already I have discussed you in previous class, and also when we will conduct laboratory experiment you will further learn about this. So, flow inside the dripper is considered as an incompressible steady state flow, and that can be described by conservation of mass and momentum equations. When we talk of conservation of mass, we are considering the control volume. So, this particular boundary which we are seeing, this boundary, and inside that there is a control volume, and this control volume it has got, let us say that it has got elemental area dA, and then there is when the water coming out means there is a some water it is getting into this control surface, and from this control surface it has got area dA. So, it is entering and then it is going out with velocity vector v. Now, so conservation of mass, it is related considering a closed system, it undergoes a change, and that change is expressed as the m system as a constant, or we can say a rate of change of mass with respect to time is 0. So, we are considering it is a steady state case. So, mass of the system remains constant during this process it takes place. So, mass balance for a control volume C V can be given by m in, that is a mass entering into the system, and then mass coming out of the system. This can be given as a d by dt m C V, that is a mass through a control volume. So, rate of change of mass within the control boundary, and the m in and m out is the total mass of flow which is getting into the system out of into the control volume, and then the water which is coming out of the, that is m out is the flow volume coming out of this system. Now, it is a steady state case. So, d by dt m C V is considered as a 0. I will say that it is 0. So, m in means the sum of the all the water which is entering in each individual units, that can be in, that is the mass which is getting into the system minus mass coming out of the system, can be expressed as, this can be expressed as rho v n dA, that is the velocity vector in the direction means your n, and this is the density of the fluid, and then this can be given by the area of the control volume. So, this is equal to 0, and then this is the another component. So, rate of change of mass flow is plus this is the total the integral of the control volume area, that is your control surface. So, rho v n dA, this equal to 0. So, this can be given finally, this equation when this becomes 0. So, this equation can be written as the velocity in the x direction del u by del x, del y v, and del w by del z, means velocity in u direction, velocity u is in x direction, y direction, and in z direction it is equal to 0, which is known as a continuity equation in the differential form. We call it as the velocity of the flow multiplied by the area A 1 V 1 equal to A 2 V 2 is the general algebraic equation, but in the partial differential equation this equation can be written in this form. The another equation which is involved when the flow takes place through the dripper is momentum equation. So, conservation of linear momentum law for a system is explained by Newton's second law. What is the Newton's second law? P equal to mf, that is the means force applied is equal to mass into acceleration. So, these forces, the rate means the rate of change of mass into velocity from the system is given by sum of all the forces. What are these forces? One is the pressure force, another one is viscous force, and third component is body force. So, the means pressure force, viscous force and body force, this particular part it can be expressed in because we are considering the control volume and we are in x, y and z direction we are considering. So, in x direction we can write this expression that the rate of change of rho u can be given by minus del p plus mu del square u plus f x. So, this is the body force, this component viscous force, and this component is the change in, that is your change in the pressure force. So, pressure force which is we can write del by del x p because it is in the x direction we are considering. So, similarly, in y direction this expression can be expressed del by del, and then this is your f y. In z direction we can express because u, v and w, these are the velocity component in the vector form I g k vector, which can be expressed in x, y, z. So, this is your and f x, x y, f z, these are the body forces working in the respective x, y and z direction. So, here the different symbols which has been used. Rho refers to the density of fluid, that is expressed in kilogram per cubic meter. Mu refers to the dynamic viscosity in which is expressed in Pascal second, and then P is the pressure, F x, x y, F y and F z, these are the component of the body forces. Now, these fundamental equations have been utilized while developing a dripper by using the software. So, this I am going to discuss here. So, we will be following certain design steps. These design steps are given in this flow chart. This flow chart explains is ideation. What is the ideation? Ideation means it is the creative process of generating, developing and communicating new ideas. So, any new ideas which are coming, if it is not only in the drip emitter, there can be any other product development, there could be any process. So, this is ideation, this particular process of thinking or bringing new ideas. So, this is the this particular term is known as ideation, and then design, it is the process of. So, next step it comes to, so some new idea has come that yes, in the market we have got the commercial dripper of 3 components. So, idea is this one, can we develop a improved dripper which is less expensive, it is economical dripper, can we reduce the size of the dripper, can we reduce the total material involved in developing a dripper, and then it should be simplified, and then in the commercial dripper whatever the problem it is existing in terms of the water which is coming out of the dripper, in terms of the operating pressure, in terms of the clogging of the dripper, can we simplify, that is the ideation, and that idea should be brought in the terms of design. So, it is the process of planning the creation of the object, that is the design part. Simulation, it refers to the process of predicting the performance of digital prototype. So, we will means once we have got, so we will simulate the things. If we are giving dimensions, then if by given those dimensions, assumed those dimensions, and if we are simulating the process, we are simulating that what will happen inside the dripper. That is the way it is, we will see that how it is functioning, and then those simulation thing, if it is satisfactory, then we will go for using a 3D printing machine, and then we will get the prototype made, and then means after getting the prototype made, we will test the product. So, 3D printing, it is the process of making 3-dimensional solid object from a digital file or set of digital files. Prototype testing, it is the process of evaluating the performance of prototype in laboratory field. So, the concept of the continuity equation, concept of the momentum equation, and then the solving those equations using the SolidWorks software. This is SolidWorks software, means these are the different tools which are shown here. So, this software is a computer aided design program which helps to draw any simple or complex shape and assembling and modeling. So, we will assemble, we will model the process by using the equations of continuity and momentum equation. So, this particular software has got certain features, and so this window which you see here, it looks means here there is a history, sensors, annotation, and what type of material, and that is the feature manager tree. There are what are the different types of commands. So, you can see here the features, sketch, then weldments, and means these are the command manager. There is a head up toolbar, and then this is a design toolbar. So, this is the product which we want to make. So, this particular design, and then we will give some certain dimensions, and then we can see the product by changing the direction. So, this we will do. So, there is a in the command manager which we were telling. So, there are different features of the command manager. It is a toolbar that dynamically changes can be made depending on the selected toolbar. So, you can see if you want to sketch, you want to make, you are finalizing that what should be the dimension, and then you want to make certain changes because the we want to make a particular shape. So, we will choose the particular shape, and that shape will be given by using the different symbol. It could be line, it could be circle, it can be ellipse. So, we will give a and polygon. So, as the water has to pass through the different shapes, so we will be giving this, and we will convert them. So, we will use the tools control tab to get the product made. Now, in this particular software, these features which are there, these toolbars, it shows that feature manager, design tree, from the feature manager tree, property manager, configuration manager, display tab, that can be accessed by toggling between the tabs at the top. So, means there are different, we will be generating the file, and then this file's name will be given, then we will specify the material as a sign, and then mass property, what is the type of material which we are making. So, we will give the assign the material property, a roller bar is used. This is what is that it is given that to go back in the earlier condition. So, this kind of a thing, this provision is there in the software. Then head up toolbar has got the there these are the features of the head up toolbar, means we can zoom to fit, we can zoom the area, we can go to the previous view, we can have this sectional view when we are cutting the product, how the sectional view it will look like, what is the dynamic annotation, view in orientation. So, this is a view orientation, display style, how we want to make display the product. So, that can be given, hide and show, edit appearance, that is the 9th tool available, apply a scene, or we want to view the setting. So, toggle views such as real view or shadow and perspective. These are the features available in the head up toolbar. So, there is a design space provided. This one, the design space is basically we will create, edit and manipulate the model, any part. So, here we will what we will do, we will assemble our parts, we will make the design, all that thing, and then we can edit if we are finding there is some changes which are to be there in the particular design when we are making. So, that also we will do in this particular tool. So, we have applied those features and then designed the single component as well as adjustable flow drip emitters using the software which I have told you. So, single component dripper, a typical commercial dripper I was telling you, it is available in the market, that is the it has got 3 component, but we wanted to reduce the total material and then it should be clogging free. So, we developed a single component dripper which is fitted in the lateral pipeline, and then also we developed 2 component dripper, and then 2 component dripper there is a provision that we can twist and bring in a particular position. So, it can be brought to 2 positions and adjust the flow. So, in position 1 it is delivering 1 discharge, and when it comes to the position 2 it comes to the second, means it gives a different discharge. So, like this adjustable flow dripper has been designed. So, adjustable flow dripper has been designed using SolidWorks 2016 software, which has 2 components. Component 1 is the base, you can see here this is the base, and then in the base there is a barb. This barb it goes inside the. So, we make a with the help of a punch hole, and through the punch hole this barb it is inserted into the lateral pipeline, and then on the top you see that there is a base component. In the base component there is a arrangement where you can change the position from one position to the second position and then adjust the flow. So, coming to the adjustable flow dripper. So, this is the base, means the bottom part of the bottom portion. So, this part is a barb and this is a ring for locking which we developed. So, this is the top view of the base of the adjustable flow dripper, which the same thing this particular component we can see in isometric view. So, inside this particular base there is a there are 2 positions which are shown. This is position 1, here there is a position 2. So, we can switch from one position to other position and this is giving different discharge. This is the front view of the base, which if you are looking, so from the top means you are seeing this is the front view and this is the side view of the base. So, different views of the base of the this adjustable flow dripper has been shown here, and then the top part of the dripper, means this is the cap. So, if I am seeing from the top view that the cap, so it looks like this, but behind this, this is the whole the theory is involved here. So, this particular component water moves from when it comes from the barb, then it moves into this one. So, you can see here the water will be coming here, it is passing through this zigzag path, labyrinth path, and finally, it will dispensing out of that. So, these are the different views of the adjustable flow dripper cap part of the dripper. So, the adjust means this is the same cap, it has been shown that the top of the cap, this is the outlet of the cap, cylindrical hole where the water will be going out. So, this is the isometric view, this is the front view of the adjustable flow dripper cap, and this is the side view. I also talked about the single component dripper. So, single component dripper, it is a simple, it is only one component which is used. So, this is the top view, this is the bottom portion where this is a barb, and then this component there are two arm here, one arm is here, another arm is here, water enters through this barb. So, there is a hole in this one. So, when water it enters, it is ejecting out of this particular hole, and it will strike on in this arm. So, this has been also designed by using the SolidWorks software, and these are the different views, top view, isometric view, and then front view as well as side view of these drippers. So, when we are simulating the flow, we are giving the boundary condition. So, boundary condition at the inlet end of the dripper, that is what I say barb. So, we are putting the means your boundary condition is 199.36, and then outlet pressure means this is the atmospheric pressure 101.32 kilopascal. So, water which is entering into the dripper, and then outlet part we are fixing as 101.32, and this is the temperature which is fixed. So, this is the now we can have a different pressures. Suppose water is entering at the different pressures, different pressure maybe we are giving it 1 bar, 2 bar, 3 bar. So, that pressure how does it behave in the out means discharge from that can be, and but the boundary condition at the outlet face means at the outlet end is remains same, that because water is dispensing at the atmospheric pressure. So, here the simulation of the pressure at different points of the dripper has been shown when the water passes from the inlet and then it goes out of the outlet. So, how the pressure at the different points in the dripper, inside the dripper, it can be seen. So, the different colors here means the red color which we see here, the dark red color, and then it's a and then blue color it is at the outlet when the. So, these are the different colors when it is passing. You can see here the pressure is reducing as it goes. So, if for a single component dripper, this part it can be shown through this animation. So, when the water is coming here, it is going there, and then it gets mixed, and then you can see how the pressure distribution it takes place from a single component dripper. Similarly, in case of adjustable flow dripper and the top view of the flow animation, and then pressure distribution can be seen in this way. In the same dripper, when we want to see in the isometric view form, so this animation it gives the how the pressure distribution when the water flow takes place, it will take place. for the same dripper I want to see from the side view. Now, after learning the and getting satisfied the flow simulation and the pressure distribution in the dripper, if it is a satisfactory, then we go for 3D printing. So, 3D printing, what we did, we used a Ray 3D printer, and this 3D printing is a process of making 3-dimensional solid objects from digital files, and then the SolidWorks, the file name is given by extension .stl file. So, this file is given to the 3D printing, and then it means it goes to the idea maker of the software, then this file converts to the G code file, then it is a 3D printer, and finally, we get the prototype product. There are some specific benefits of using the 3D printing, because making mold for each and every object it becomes a difficult task. This is a cheap, and then it is a time effective, it is a cost effective, there is a freedom of design, you can change product, you can customize, this is a faster production and reduces the wastage of time, wastage of material, wastage of money. So, a 3D printing machine there is a it is idea maker, is a slicing software that prepares the 3D models for printing and turns them into G code file for Ray 3D printer. So, this is the the product model preview before it goes for printing. So, we see the product, how does it look like, and then it is given for printing. So, this particular printing machine, these are the different tools. So, it includes tools for all the operation command and advanced settings. So, these are the different add, delete, view, pan, move to XY coordinate, rotate the particular product and see in a different angle. You can modify or amplify the size, you can have free cut, maximum fit, we can duplicate, we can repair, we can connect. So, till we are not satisfied, we can make several changes in the machine. Now, a machine look like a 3D printing. This is a idea maker in the software, where we see on the machine in a software which is in your laptop, this we can see, and then that product it is brought here for seeing. So, you can see here how the 3D printing it is used for developing the dripper. So, it is a 3-dimensional thing, it is going x, y, and then it goes on the vertical side also. So, finally, we get the product made out of the dripper. We developed some certain product. You can see here this particular component is the barb, and this is a single component dripper. So, barb is actually basically this will go inside the lateral pipeline, and in this stem there is a outlet provided, and these are the two arms which I was showing you there when we were designing, and this is just one component which is used, and this we have developed by using the SolidWorks software design we made, and then we with the help of 3D printer this single component dripper has been developed. After we make this particular product, then we go for mass multiplication by making the mold. So, this is the one particular product. Similarly, we developed another product. This is a 2-component adjustable flow drip emitter. So, I was telling about the base part. So, base part of the this dripper is this one. It is a two component. You can see here these are the two components. This is a one component, that is a base of the component, and this is the cap, top part, and in the cap, but in the base this particular component is the heart, means this is the main thing where the water is passing through this zigzag path. Star is made here. You can see here the water. So, water will be coming from this dripper, it will come out of from this point, then it will get into this, then after it comes to this place, you can see here, then it will go, it will pass through this zigzag path, and finally it will come out of this. So, same thing here also, we prepared design by using SolidWorks software, and then we got the product made by using 3D printer. So, first we made base, then to suiting to this base we made it the cap part. Now, here there is a provision for this, that we can shift to the two different positions. So, here the provision is made that if you make it the particular position, it will get locked, and then water will be coming in one particular discharge rate. When we shift to the another position, we can bring it to the another discharge. So, like this, that is a locking provision, and after we get satisfactory results, then we will go for making final mold, and then we will do. Similarly, we made several changes in our design. This is also a two component dripper. You can see here one component base, which I was telling you, this is a circular base. So, this is a single component, and this is the there are two components. So, here also it is adjustable flow rate, and then when we are tightening it, means this is the case, when we are, this is a fully open, means it will be giving maximum discharge. So, water will be entering into this, it will come out of this. So, as you keep on closing, so there is a slot inside, then the opening will reduce. So, like this there are different ways, the different types of dripper that can be made. This is also a two component dripper. So, we made several trials, and for getting the best product out of this by using these technologies. So, this is a same thing which I have told you. So, this is a single component dripper, and means this where these are the things which we made, need only one mold to manufacture, low manufacturing processing cost, means low raw material cost, operate at wide spectrum of water rate, water is discharged at the root zone, easy unclogging and maintenance, less energy consumption for operation. So, these are the features. This is the another single component dripper that has been made. So, means single component flow regulator. Here in single component only one particular discharge it is giving, but here we can regulate the flow. So, again provision has been made that it can be regulated, and this is the two component flow regulator, need only 4 molds to manufacture compared to 6 or 3 component system. So, here a low manufacturing cost, low raw material, flow can be regulated easily. So, these are the some of the features of different types of drippers, where the software like it has been, and this is what you see when we are attaching with the lateral pipeline. This is a single component, and this is a double component adjustable flow dripper when it is being used. And then we evaluated these drippers and tested in our laboratory conditions, and when we kept it in a hydraulic bench. So, we will come to the laboratory class and give you more detail about testing of the dripper, but I would like to show you some of the results of this particular dripper when we are operated this particular dripper at different heights, and there is a relationship. It looks like in this form of the equation, which is given by q equal to 1.97 s to the power 0.54. So, which is the orifice flow equation. Similarly, you can see here this is for the pressure discharge relationship for adjustable flow dripper when the dripper is at position 2, and this is for the single component dripper when the dripper is operated at different pressures, and this is the nature of graph, and then the equation is has been developed for this graph is q equal to 2.38 s to the power 0.55. So, where h is in meter and discharge in liter per hour, and x is the, and then we tested the for single component dripper what is the simulated value and also for the measured values. So, these things we also. So, finally, these drippers we can the results obtained from the dripper can be summarized. The designed single component dripper can be operated at low pressure, that is less than 1 meter at a, and then also it can work up to 10 meter height, but we will get a different discharges. So, single component dripper discharge rate is as low as 1.18 liter per hour and as high as 8.33 liter per hour. So, when we have got different pressure, we will get higher discharge, and a designed adjustable flow drip emitter can deliver different discharges at the same inlet pressure. Hence, the discharge from the emitter can be regulated as per the craft water requirement. In adjustable flow emitter position 1, discharge ranges from 2 liter per hour to 6.99 liter, means this is at position 1, and when we and also at position 2 it is from 5.36 liter to 17.71 liter per hour. The single component emitter and adjustable flow emitter are orifice type of drip emitter, as we have seen that the exponent is 0.55. So, for more detail you are advised to go through these references so that you get better more idea. So, let us summarize this particular lecture. We have tried to learn about the drip hydraulics, and there are different design steps. We we made design and simulation using the SolidWorks software. We used the Idea Maker software for the 3D printer and developed the dripper and also tested the hydraulics. And then in the forthcoming class, we will work out numerical problems dealing with drip irrigation system. So, thank you very much.